Welcome to the large-scale shake table facility in the Department of Civil and Environmental Engineering in the College of Engineering at the University of Nevada, Reno. The custom-built shake table was completely designed at the University of Nevada, Reno to specifically study the response of soil structure interaction subjected to earthquake shakings. The shake table is a bi-axial table including yaw rotation, with a system of concrete buttresses, individual concrete blocks, and through compact V configuration of 8 actuators. It has 13 inches of stroke in each direction and applies 1.1 to 1.2 million pounds of force in both X and Y. The platen sits on a system of 8 hydrostatic bearings that ride on a thin film of oil that's 2,007 inch thick. This stiff film of oil maximizes capacity and is practically friction-free. The bearings are oriented on the perimeters of the shake table to maximize our ability to overcome the roll and the pitch moments coming down from the box. This perimeter configuration is optimal for our platen. The platen itself is 24 feet by 24 feet. Because of its size, it was fabricated in 9 pieces and assembled and welded over a 3 to 4 week period. Because of the power of the actuators and the tendency for platens to move at high velocity, the system requires a lot of hydraulic oil and flow. Our extensive and custom hydraulic piping distributes oil at a velocity of 40 inches a second, enough to handle most earthquake motions. The laminar soil box consists of alternating layers of rubber bearings and 19 steel frames. The orthogonal box is 21 feet across, 15 feet tall, and can hold 350 tons of soil. Because the soil box is built into 3 5-foot segments, the sections can be swapped to facilitate many different research ideas. At its base, the alternating hollow tube steel frames are heavier than those at the top. Similarly, the 408 rubber bearings begin with the stiffest at the bottom. As you go up, the stiffness decreases and the number of bearings per layer as well as their size changes. This arrangement accommodates changes in the stiffness of the soil. As a result, the box can achieve a 2% strain inside the soil. The orthogonal shape allows for the box to move in 2 directions while facilitating instrumentation in the corners. In addition to this bidirectional design, the angles at its bottom further engage the soil through shear action. Stiff rubber on the faceplates accommodates complementary shear, allowing researchers to reduce the zone of disturbance. On the outside of the soil box, K-knot frames ensure it stays straight during assembly while eliminating shear stress. A collaboration of the Department of Energy, the Lawrence Berkeley National Laboratory in Berkeley, California, and the University of California, Davis. The many applications of the large-scale shake table facility include research that is designed to enhance the seismic safety of DOE and nuclear facilities. As such, it supports the goal of the Department of Energy to develop natural hazard resiliency of DOE mission-critical facilities and secure public safety, and represents another avenue for the researchers to pursue multi-agency research that raises the bar for the field.